Hello and welcome back. We're about in the middle of our unit on circles. And speaking of the middle, we're talking about inscribed angles today. And that word inscribed kind of tells you about the angle, because that word scribe, that means to write. And if you're in writing an angle, you've got an angle inside a circle. So that's what we're talking about today. Angles that are inside circles. Here we go. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. For example, DEF is an inscribed angle. And in circle G, minor arc DF is called the intercepted arc for the inscribed angle DEF. It sort of catches that arc. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. Well, what does that look like really? Well, here we have a circle and angle ACB is 44 degrees. So how would we find the measure of arc AB? Well, we just have to take 44, multiply it times 2, and we get 88 degrees. Let's try it the other way. We know that the measure of arc YZ is 90, so how do we find the measure of angle X? Well, from 90, we divide by 2, and we get 45 degrees. If two inscribed angles intercept the same arc, or congruent arcs, then the angles are congruent. Let me show you what that means. Wow. Okay, that looks confusing, but look at this. See that angle there? It intercepts the arc WX. This angle also intercepts the arc WX. So that means that angle Z and angle Y, well, those are congruent, which means 3x minus 23 equals 2x plus 2. And we can solve for x. Now, once I know that x is 25, I can find the measure of angle Y by just sticking 25 back in for x. So 2 times 25 plus 2 is 52. I can also find the measure of angle Z. 3 times 25 minus 23 is, well, 52 still. Now, what about the measure of angle W? Okay, let's look at this for a second. Angle W intercepts the arc ZY. Angle X also intercepts the arc ZY. X is 22 degrees, which means W is also 22 degrees. An inscribed polygon is one whose sides are chords of a circle and whose vertices are points on the circle. An inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. Okay, so let's look at this. Here we have an inscribed polygon. All the sides are chords and all the vertices are points on the circle. Now, this inscribed angle, because it intercepts a diameter, we know that this inscribed angle is a right angle. Let's say we want to find the measure of angle A. Well, we can solve for x. 90 degrees of the triangle is already taken up by that right angle, which means there's 90 degrees left. So 3x plus 6, the measure of angle A, plus x, the measure of angle C, equals 90. And we can solve for x. X equals 21. We can plug that back into the measure of angle A to find the actual measure of angle A, which is 69 degrees. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Let me show you. Here we have a quadrilateral, a four-sided polygon inscribed in the circle. So now we know that angle E and angle G, those opposite angles, are supplementary, meaning they add up to 180. So again, we can use that information to solve for x, and x equals 9. Now, if we want to find the actual measure of angle G, we just plug that 9 back in. 8 times 9 plus 1 is 73 degrees. So we talked about inscribed angles and inscribed polygons as a bonus. Thanks for being here.